The humble bumblebee. Fuzzy, adorable, yet a vital player in our ecosystem, responsible for pollinating crops across the country. But what happens when these critical pollinators come in contact with widely used pesticides? Researchers set out to answer this question by testing the behavioral effects of a popular insecticide, imidacloprid, on colonies of bumblebees. They chose bumblebees due to the size of their colonies, which are much smaller than honeybee colonies, making it easier to observe individual bees. To track their behavior, each bee was outfitted with its own small, waterproof 2D barcode that would allow a robotic camera to record the movement of each bee individually. The colonies were separated into different tracking arenas, each consisting of a nesting area and a foraging area. The bees were given access to nectar with varying concentrations of imidacloprid, similar to what they might ingest out in the wild. The scientists used a camera mounted on a custom robotic chassis to periodically check in on each colony. Their findings were striking. Within 24 hours, colonies that were exposed to the pesticide exhibited a range of behavioral changes. The bees were lethargic and had fewer social interactions. The bees also foraged less and spread out from the center of the nest towards the periphery of the colony. The researchers also wanted to test insecticides' effects under more realistic conditions, so they set up 6 colonies outdoors, equipped with thermal sensors. Each colony was given access to either pure nectar or nectar containing imidacloprid. The researchers measured the surface temperature of the colony and the air temperature inside and outside the colony. They found that colonies that had ingested the imidacloprid had trouble regulating the temperature of the nest, especially as temperatures outside began to dip. These colonies were also less likely to construct a protective wax canopy around the developing young than colonies that had eaten only pure nectar. These behavioral changes may seem small, but when combined, they can have drastic effects on the nest as a whole. Researchers believe that this study highlights the need for a better understanding of how insecticides and other agricultural chemicals can negatively impact ecosystems.